Assalamu alaikum. Today we will discuss R's complement. Let's start. First of all, we will see that why the complements are used. Basically, the complements are used for the subtraction operation, that is arithmetic operation. As we have discussed arithmetic operation involves subtraction, addition, division, multiplication, etc. as we have discussed in the last lecture, right? So the subtraction operation, which is a part of the arithmetic operation, is basically eased or it is easily solved by using the complement, right? So first of all, we will see that for each radix R system, that is in radix R represents base of the number system, right? You can say here that let's say that we are talking about the binary system, right? So in the binary system, the base, that is radix R, is 2. And similarly, if we are talking about decimal number system, then the radix R will be 10. So now let's discuss that there are two types of complements: 2's complement and R's complement, which is also known as R's complement, right? R's complement is also known as the radix complement, and in the binary system we will say the R is 2, right? So we will say it is 2's complement, let's say, in the binary system. And the other type is diminished radix complement. It is also referred as R minus 1's complement, and in the system 2 minus 1, R is 2, as we have discussed that R will be 2 in the binary system. So 2 minus 1 is 1, so once it will be 1's complement. So in the binary system we will have 2's complement and 1's complement, right? Let's discuss binary system complements, which are 2's complement and 1's complement, right? As written in this line that it is 2's complement and 1's complement in the base R equals 2. First of all, we will discuss what is 1's complement. Now we will say that we can take a 1's complement of a number by changing all the 1's to zeros and all the zeros to 1. We can also say that we can change the bit to 0 or we can change the bit to 1. Let's see the example. Here the given number is 10101, right? And we have to take the 1's complement of this number. Let's start with the least significant bit, which is 1 here, and we can also say that we will go from right to left, right? So first of all, we will change the 1 to 0, right? Then this 0 will be changed to 1, 1 will be changed to 0, 0 will be changed to 1, and 1 will be changed to 0. This mechanism is done. Why? Because we have discussed in this line that all 1's will be changed to 0 and all zeros will be changed to 1's, right? So in this way we will take 1's complement, right? Okay, now it is another example, 101100. Okay, let's take the 1's complement of this number. So it will be 010011, right? It will be the 1's complement of this number, right? Because 0 is changed to 1, 0 is changed to 1, 1 is changed to 0, 1 is changed to 0, 0 is changed to 1, and 1 is changed to 0, right? So it will be the 1's complement of this number, right? And this is the example which will be solved by you people for your practice, right? Okay, now discuss what is 2's complement. So if you have learned that what is 1's complement, then it is easy for you to learn that what is 2's complement. Simply add 1 with the 1's complement and you will get the 2's complement, right? This line and this line is same. It is simply written in the formula and it is simply written in simple English. The 2's complement of binary number is obtained by adding 1 to the least significant bit of 1's complement of the number, right? 1's complement plus 1 is equal to 2's complement. So let's discuss with the example. This is the given number 10101, right? So first of all, we will take the 1's complement, and all you have learnt now that all ones will be changed to 0 and all zeros will be changed to 1, right? 1 to 0, 0 to 1, 1 to 0, right? And we will add 1 with the least significant bit, right? As we have discussed here that 1 will be added to the least significant bit. So we will add 1 with the with what? With ones complement, right? You will add 1 with the ones complement. You will not add 1 with the given number, right? You have to learn that 1 will be added with the ones complement. So 0 plus 1, 0 plus 1 is 1 and 1 will be written here 0, 1, 0, right? So we will get the answer 0, 1, 0, 1, 1. It is the 2's complement of the given number here 1, 0, 1, 0, 1, right? Okay. Now there is another example of 2's complement here 1, 0, 1, 1, 0, 0. First of all, we will take the 1's complement here, which is 1, 1, right? Zeros are changed to 1s, 1, 1 is changed to 0, 0, and 0 is changed to 1, and 1 is changed to 0, right? Then we will add 1 with the 1's complement as we have discussed in the above slide, right? So 1 will be added here. 1 plus 1 is 0, 1, 0, 1 is carried, right? So 1 plus 1 is 0, 1, right? And the 1 is written here and the other 0, 1, 0 will be written as above, right? So the result will be 0, 1, 0, 1, 0, 0, right? And it is another example 0, 0, 1, 1, 0, 0, right? We will take the ones complement of this number and then we will add 1 with the ones complement, right? And we will get the answer, which is 1110100. You will solve this by yourself so that you can do practice on this example, right? Okay. Now we will discuss that what is as we have discussed that basically we are doing the complements because we have to simplify the subtraction operation, right? So now we will learn that how the subtraction operation will be performed by 2's complement. So with the help of subtraction by 2's complement method, we can easily subtract two binary numbers simply, right? We are doing only to simplify the subtraction operation. The operation is carried out by means of the following steps. We will perform these following steps. Now, these steps are very important, right? These 4 steps are very important. We will discuss these 4 steps and then we will go on the example and then we will again come on these steps so that you can learn these steps properly, right? Because they are the base for the subtraction by 2's complement. So let's discuss the first steps. First of all, you have to take 2's complement of the subtrahend, right? Subtrahend, then you have to, then it is added to the minuend. The 2's complement of the subtrahend is added to the minuend, right? Then if the final carry over the sum is 1, it is dropped and the result is positive, right? And if there is no carry over, the 2's complement of the sum will be the result and it is negative. So let's discuss with the example. 110 minus 10110. You have to solve this by doing the 2's complement. So first of all, as we have studied in the above slide, that first of all you have to take the 2's complement of the subtrahend, right? Subtrahend is this one which is you have to subtract, which you have to subtract is the subtrahend, as this is written also here, right? So first of all, we have to take 2's complement of this number, but as they are 5 digits, as we have seen 1, 2, 3, 4, 5, and this is 6-digit number. So we will add a 0 here so that it will be a 6-digit number also, right? Then we will get 0, 1, 0, 1, 1, 0, as we have added a 0 here, right? Now we will first of all take the 1's complement of this number, which is as we have learned that we will change 0 to 1, 1 to 0. Okay, we will take the 1's complement of this number and we will get 101,001 as every bit is changed to, and 0 is changed to 1, 1 is changed to 00, 0 is changed to 1, and 1 is changed to 0, and this 0 is changed to 1. So we will get 101 001, and we will add 1 to this least significant bit, and the answer will be 101010. Now we will add this 101010, which is the 2's complement of this subtrahend, right? We will add this to the minuend, right? This is 11101110. It is written here, it is minuend, and 101010 is written here, which is the 2's complement of the subtrahend. When we add this number, we will get 1000000, right? And the carry is 1, right? So now we will see that if the carry is 1, then what will be the case? So we will again go on the above slide and we will check the condition. Look, the condition is if the final carry over the sum is 1, which is the condition here in this example, then what we will do? We will drop the 1. It is dropped, right? The carry is dropped and the result is positive. And the result is positive, right? So what we will do? Now this 1 is dropped. So this will be the final result and this result will be positive, right? So it is also written here, after dropping the carry over, we get the result of subtraction to be 1000000. Now we will check another example here so that you will be clear for the 2's complement and the subtraction by 2's complement. So the example is 10110 minus 11010. Now first of all, what we will do? We will take the 2's complement of the subtrahend, which is this 11010, and first of all we have to take the 1's complement and we will get 00101, and then we will add 1 to the least significant bit of the 1's complement and we will get 00110. Now what we will do? We will add this 2's complement to this minuend, right? So this minuend is added to the 2's complement of the subtrahend, and by adding this, look, we will add 0 0, we will get 1. 1 plus 1, we will get 0 and the 1 will be carried. 1 1 1 means triple 1, we will get 1 and the 1 will be carried here. This 1 will be we will put the 1 here, and this 1 plus 0 is 1. So we will get 11100. Now the case is that we have no carry here, right? We have no carry here. Now we will check the condition. If there is no carry, then what we will do, right? So we will check if there is no carry over, the 2's complement of the sum will be the result and it is negative, right? What we will do? We will take the 2's complement of the sum again, right? And it will be negative. Now let's go again to the example. It is the result 11100. What we will do? We will, as we have no carry here, right? So we will take the 2's complement here again of this 11100, and what we will do? We will take 1's complement, right? 1's complement, which we will get 00011, and we will add 1 because we are taking the 2's complement, as you know. So we will get the result 00100, right? So the answer is 100, which will be negative. Why it is negative? Because we have learnt in this clause that if the carry is there is no carry over, as the case is in this example, it will be, the result will be negative, right? And we will take the 2's complement of the sum as we have taken, and we have the number 100, right? And it will be negative. Okay. Now these are the two examples are written here for your practice. Now we will study that how we will do the subtraction by using 1's complement. So as we have studied that how we will do the subtraction by 2's complement, and we have the steps. Similarly, we have the steps here also, which is to write down 1's complement of the subtrahend. To write down the 1's complement of the subtrahend, first of all, we will take the 1's complement of the subtrahend. To add this with the minuend, we will add this with the minuend, and then we will see if the result of the addition, has a carry over, then it is dropped and one is added in the last bit, right? And if there is no carry over, then 1's complement of the result of addition is obtained to get the final result, and it is negative. Now let's discuss another example. 101011 minus 11100. First of all, what we will do, we will take the 1's complement of the subtrahend, which is 11100, right? We will get 0001110, and we will add this number to the minuend, which is 10111, which is written here, and the 1's complement is written here. Now we will add this. 1 plus 0 is 1, 1 plus 1 is 0, the 1 is carried here, 1 plus 1 is 0, the 1 is carried here, 1 plus 1 is 0, the 1 is carried here again, and the 1 is written here, the carry 1 is written here, right? And 1 plus 0 is 1. So we will get 111001. And as you have seen that there is no carry in this case. So if there is no carry in this case, we will check the clause that what will be the case. This is the clause. If there is no carry over, the 1's complement of the result of addition is obtained to get the final result, and it is negative. The result will be negative, and we have to take the 1's complement of the result. Now let's go again with the example. This is the result. We will do the 1's complement of this 111001, and we will get 00110. As you know that 1 is changed to 0 and 0 is changed to 1 for taking the 1's complement, right? So we will get 1110 as this 1110. We can write it as 1110, and the minus sign is here because there is no carry over, as we have checked in the clause of the 1's complement for using it in the subtraction process. Now this is another example. 1011.001 minus 110.10. First of all, what we will do, as there are 3 digits here and it is 4 digits here, so we will put a 0 here. 001 is there are 3 digits here and it is 2 digit here, so we will put a 0 here also. So what we will get? We will get 0110.100, 0110.100, right? This number. Now what we will do, we will take the 1's complement, which is 011, right? And it is 1001, as you have seen here, right? Now it is added to the minuend, which is this number, and it is written here 1011.001, and this 1's complement of the subtrahend is written here, right? Now what we will do, we will add the result and we will get 0100.100, but there is a carry, which is 1. Now what we will do, we will check the clause that what will be the clause, right? So we will again go the condition. The condition is if the result of the addition has a carry over, then it is dropped, right? And 1 is added to the last bit. Now they check that the condition is different from the subtraction by 2's complement, right? We will drop this and we will add to the final result. So we will again go to the example and we will drop this and we will add it to the final result. Now the result will be 0100.101. Hence the required difference is 100.101, right? Okay. This was the binary complements, 2's complement and the 1's complement. Now we will check the decimal complements. First of all, we will take the look into the 9's complement, which is r minus 1's complement, right? 10 minus 1 is 9's complement, right? So it is 9's complement. You have to simply take, you can do this like, for example, you have 4, 5, 6, like there are 3 digits. So what you will do, 10 raised to power n minus 1. 10 raised to power n is, there are 3 digits, so it will be 10 raised to power 3 minus 1. And it will be 10 raised to power 3 is, as you know, it is 1000. So 1000 minus 1 is 999. So you will subtract the 4, 5, 6 from the 999. It is one way, and another way is that you have to subtract each digit from 9, right? So both are written here in this line. Let us take a decimal number 456. 9's complement of this number will be 999 minus 456, and the answer will be 543, right? And for taking the 10's complement, simply you have to take, first of all, you have to take the 9's complement of the number, and then you have to add this 1 into the 9's complement. As you have seen 10's complement or 456, first of all you have to take the 9's complement of the number, which is 456, and we will take the 9's complement by the same process here, that you have to take the subtraction from 999, or a single digit is subtracted from 9, right? So we will get 543, and then 543, a 1 is added into the least significant of the 543, right? And we will get 544. In this way we will get the 10's complement. Let's check with another example. 9's complement of 7809 and 10's complement of 7809. So what we will do, we will subtract it from 4 nines minus 7809, right? And we will check the result. It will be the 9's complement. The result will be 9's complement, right? Which is 0, right? 9 minus 9 is 0, and 9 minus 0 is 9, right? And 9 minus 8 is 1, and 9 minus 7 is 2, right? Okay, so we will get 2190, which is the 9's complement, and simply we will add the 1 and we will get the 2191, which is the 10's complement of 7809. This is another example for your practice. Okay, now we have learned that how we will take the 9's complement and 10's complement. Now we will learn that how we will do the subtraction by using 9's complement. As we have learned that subtraction is the main issue and the main process for which we are studying the complements, right? So let's take an example, a minus b, which is 215 minus 155. So first of all we will take the 9's complement of the subtrahend, which is 155. So 9's complement of the subtrahend is 999 minus 115, and we will get 844, right? Then what we will do, now we have to add 9's complement of b to a, right? Which is 844 is added to a, which is 215, and we will get 1059. Now we have the carry. The leftmost bit of the result is called carry and is added back to the part of the result without it. The condition is here that as we have checked the conditions is 1's complement and 2's complement. Similarly, the conditions are also for 9's complement and 10's complements also, right? So for 9's complement, if the carry is 1, then what you will do, it will be added back to the part of the result, right? So it will be dropped from here and it will be added back to the result, 059 plus 1, and we will get the result, which is 60, right? Now we will take another example, which is 4567 minus 1234. First of all, what we have to do, we have to take the 9's complement of 1234, and we will get 9999 minus 1234, and we will get to 8765, right? Then adding 9's complement of b, which is this 8765, and 8765, it is also written here, and it will be added with a, which is 4567. And we will get the result 13332, right? Adding the carry with the result, what we will do, we will drop the 1 and we will add here and we will get 3333. And now the answer is minus 3333. If there is no carry, the answer will be 9's complement of the answer, right? If we have seen the example with the carries, right? So we have added back to the answer. But if the case is that you have no carry, so what you will do, you will take the 9's complement of the answer again, right? As we have done in the binary complements. Now let's check the subtraction by 10's complement. Again, we will show the procedure by an example. Taking the same idea, 215 minus 155, first of all, what we will do, we will take the 10's complement of the subtrahend, which is 155, right? And we will get 845, and then we will add into 215. We will get 1060, right? Then in this case, the carry is omitted and the answer is 60. Simply we have to omit the carry in the case of tens complement, right? And taking another example, 4, 5, 6 minus 1, 2, 3, 4, we will get 8, 7, 6, 6 by taking the tens complement of B, and then we will add into the 4, 5, 6, 7, and we will get 1, 3, 3, 3, 3. Adding tens complement of B with A, we will get 1, 3, 3, 3. To get the answer, the carry is ignored. Simply we have to ignore the carry, and the answer will be minus 3, 3, 3. If there is a carry, then the answer is the tens complement of the sum obtained, right? So thank you so much for watching the lecture.